This is Project Group 7's Umbrella LCA on how production of an umbrella affects our environment by Kevin Arnold, Sophie Owen, Alan Gravot, David Rypkema, and Shannon Dowling. On the following slides, we will go into our motivations for conducting this LCA. Why we chose an umbrella. The concept of the umbrella dates back to ancient times where Greek, Roman, and Egyptians all used some form of an umbrella-styled shading device. Around the middle of the 18th century, handheld umbrellas became more widely accepted among male consumers and increased their ubiquity. During the 20th century, advancements in technology allowed for the creation of more complex umbrella design and the ability to mass-produce them. While modern umbrellas include many recyclable parts and can be easily repaired, it has become more common for consumers to simply throw it out and purchase a new one instead. Today, all kinds of different umbrella types are common across the globe. According to a 2014 article, China alone was able to produce 500 billion umbrellas per year. The intended audience for this study would be consumers interested in rain and sun protection equipment and manufacturers who produce such products. Consumers can use our study to base their decisions on whether or not they should purchase this product or possibly an alternative. In addition, our study could reveal if the product has a design that permits easy repair, reuse, or recycle, or a design that encourages throwing it away when it malfunctions. It can also assist manufacturers of products similar to this one with information pertaining to the process and materials of production. It is possible during this study that we may reveal that certain materials or processes could be a worse decision than an alternative, and it is possible it could reveal that it is actually a better alternative than a different material or process. Either way, this study will provide information that can assist consumers or manufacturers one way or another when it comes to making decisions that involve this product. In the following slides, we will address the goals and scope of this project. By analyzing umbrellas, we hope to understand the environmental impact of a product that has such a short life cycle. The product is useful when it is operable, however, once it is defective, the umbrella most likely will be sent to a landfill rather than be repurposed, reused, or recycled. We would like to compare whether its short, purposeful life is worth the energy used to create and get the umbrella into the consumer's hands. While an umbrella is clearly different than a product such as a solar panel of which you can measure an energy output, we would like to try to associate a value to how helpful the product is and assess its worth. An umbrella is used to keep water from getting on its user. Our chosen umbrella is composed of a polyester canopy, a plastic tip and button, metal framework that aids in its expansion and retraction, a faux leather strap for carrying purposes, and a wooden handle. Here is our initial flowchart we made representing the manufacturing process by which an umbrella is made. This helped us gain an understanding of what we need to do more research into and how each aspect of our current umbrella was manufactured. Here we have our cradle-to-grave study. The system boundaries for this LCA will extend from the collection of raw materials, assembly, distribution, use, then on to the disposal of parts or whole. Assumptions. We are assuming that the initial process from raw materials to manufacturing take place overseas while transportation, distribution, and usage occur to and in the United States. Functional unit. Protection from rain for 100 days of use. Modeling assumptions. Rate of recycling remains constant. Frequency of use remains constant. Efficiency of use. User height remains constant. User velocity remains at 0. Density and chemical composition of rain remains constant. Acceleration due to gravity remains constant. And wind factor is negligible. So here we have our impact indicators. And cumulative energy demand was chosen to better understand how an umbrella's energy demand compares to how many of them are thrown away and not recycled. Global warming potential was chosen to quantify how the production and disposal of so many umbrellas affects the world's growing issue of global warming. And our method of impact assessment was standalone, and it was chosen to showcase the necessity of the product with the resultant positive action of not getting wet when it rains, comparable with the negative environmental impacts. And on the next slide, we will go over our literature review findings. In order to better understand our product and its life cycle, we did a literature review and read LCAs and other articles of component materials of our umbrella. So here we have the literature review findings for the canopy of the umbrella, which was made out of polyester. And on this slide, we have the literature review findings for the handle, which was made out of wood and polyethylene plastics. And lastly, we have the literature review findings for the shaft and ribs of the umbrella, which were made out of stainless steel. And on the next slides, we will go over the model and methodology of our LCA. Our model covers disassembly, inventory data and design for the experimental, product system flow, and discussion. For disassembly, we have the canopy, which is a single-layer polyester shading surface that is attached to ribs folding in and out. The ribs, which assembly that includes multiple components made of stainless steel and aluminum, connect from shaft to the canopy and includes hinges that allow for folding action. The shaft has assembly that includes multiple components made of stainless steel. It's the main structural spine of the umbrella, connecting a handle piece at the bottom to the ribs and canopy above. Includes runner piece that anchors ribs to the shaft and slides up and down during folding action. The handle is a wood covering allowing for firm grip at the bottom of the shaft. Includes plastic button that connects to a stainless steel spring inside the shaft. This button controls the opening mechanism for the umbrella. Input and output sample inventory data is shown. For the sake of space, we only showed one input/output from a total of 1,734. From this data, we see that the redesign needs to maintain product's function and product manufacturability within the current facilities. This reduces cost as much as possible. Weight of the product needs to be kept at a minimum to reduce energy consumption and transportation. Disposal of the umbrella is important as it is the main contributor to umbrellas being a threat to the environment. On this slide, we have a graphic showing the product system flow for our umbrella. Here we have a continuation from the previous slide of the product system flow. Both models helped us gain an understanding that additional research needs to be done. They also showed the specific details that went into how the current umbrella was manufactured. From these models, we realized that the entire umbrella is being landfilled. We decided that a redesign could incorporate material reuse, so recyclability in the redesign is important. The models also showed that transportation goes into each step in the production process. There's really no way to eliminate this, but reducing by building a manufacturing plant closer to where all the materials are and where the umbrellas will be used and disposed. Now that we've gone over the model and methodology, let's look at the LCA's results. To explain the results of our LCA, we will go over the impact indicators, significant issues, our design for the experimental portion, and any limitations we felt we encountered throughout the process of building and researching this LCA. This graphic shows the impact indicators via OpenLCA for our original umbrella. It has market for steel, aluminum, 2 types of plastics, transport, and wood. For our significant issues, we found the overall global warming potential to be 0.921 kilograms. These numbers will guide us in our redesign where we want to limit the use of plastics. This is because while metals contribute the most, they have a higher durability and rate of recyclability, reducing the number of umbrellas that need to be manufactured. Design for the experimental. Since more of the product is made of the same material, it is more easily recycled. Metal is easier to recycle due to its processing at high heat, which allows for less contamination to persist in the material. This is much harder to do with plastic. Because of this, we chose to continue to use lightweight metals, which umbrella users are familiar with, that are used in the shaft and ribs, to provide continuity for recyclability. The amount of recyclable material, although initially energy intensive, will pay off after recycling. The canopy, however, will most likely remain a polyester material due to its lightweight nature and hydrophobicity. Here is a product system flow for the new and optimized umbrella. Our optimized impact indicators were created based off of our redesign of the umbrella. Our results are as shown. Overall, 0.723 kilograms global warming potential. Metals contribute 67% at 0.596 kilograms, and plastics now contribute 19% at 0.170 kilograms. As you can see, we did increase our kilogram production for steel, but we also decreased our kilogram for plastics. In fact, we got rid of polyethylene completely. While this may be a concerning number at first glance, it is important to remember that recycling, which is the point of our redesign, has great results for metal. While virgin steel does require greater material and energy inputs during manufacturing, its ability to be recycled and reused greatly increases its life cycle. If the steel can be sourced from recycled steel, it would largely decrease its environmental impacts. It also benefits from using aluminum in place of the steel. Having more metal components results in a stronger design and minimizes the need to produce a higher quantity. This umbrella would last longer while at the same time be simpler to produce due to more uniform material choice. This uniformity will greatly increase the ability to fix and replace parts that do break. This reduces the number of umbrellas that are discarded and new ones being purchased. In the event that the entire umbrella does need to be replaced, the reduced amount of materials makes it easier to be properly recycled. Limitations for our LCA. Researching data for the different materials often led to situations where only certain products were being studied and very little data was provided for specific products like umbrellas. Manufacturing data is most likely for large-scale manufacturing and excludes much of the umbrella's necessary components. Wrap up and main takeaways. For us, umbrella design can be optimized. Recyclability can be increased if more components are made from one material, and for us, that meant we chose metals. And the ultimate goal to reduce global warming emissions was achieved. In general, LCAs are a good way to gauge a product's effect on the environment, but not all products have enough data to gauge it accurately. We learned a lot about the process behind creating an LCA and what data is needed for doing so. We gained a better understanding and awareness for the complex process and impacts involved in the life cycles of what can easily seem like simple, everyday products.